Okay, so the product rule is all about how do we differentiate something when we have two functions that are being multiplied together. Okay, so it's going to be a bit different than if you had like two functions being added or subtracted together. With adding and subtracting, you can kind of look at each term and just differentiate it individually. However, when multiplication's going on, things change. Okay, so essentially what's in this box that I've highlighted in pink here is the basic formula for how you're going to derive. Both this one and this one say the exact same thing, just in different ways. Okay, so I'll explain what they're saying. Okay, so this is saying, okay, if you're taking the derivative of two functions being multiplied together, then essentially what you're going to do is you're going to derive, I'm going to call f of x the first function. Okay, so derive the first function. And then this one, it's you don't derive it. Maybe I'll do that in a different color. You leave the second function alone for the first term. Let's say don't derive. Okay, so leave it alone. Okay, so you're multiplying the derivative of the first function with the second function, which you have not changed anything about that second function. Okay, and then you're going to go plus, and then you're going to leave the first function, so you don't derive our first function, which is f of x. So leave it alone. But you're going to multiply that with the derivative of the second function. Okay. Oh. Where did all my writing go? Okay. So me personally, I like the second way of saying this, just because it's less cluttered, but both say the same thing. So take the derivative of the first function, multiply it by the second function, which you haven't done anything to, and then add it to the product of the first function with the derivative of the second function. Okay, so I like the second way just because it's less cluttered, easier to just like tell what's going on. Now, if we take a look, I'll switch back to our notes in a second here, but if we take a look at our formula sheet, that product rule, it's in your formula sheet. It's just written slightly differently, but it's still saying take the derivative of the first function, multiply it by the second function, and then add it to the product between the derivative of the second function multiplied by the first function. Okay, so you do have that given to you. Okay, so let's start off with something that's not too bad. Okay, and what I'm going to do is just label the functions so that they're easier to tell. So we're asked to differentiate f of t, which is equal to 2t to the power of 5 times by h of t, where f and h are differentiable functions. Okay, so let's go. This is going to be, I'm just lining this up with our formulas given, so I'm just going to call this our first function, that 2t to the power of 5, and then the h of t, I'm going to call it our second function, so g of x. Okay. So the derivative of this, and I'm just writing out the formula here so it's easy to see what's going on. So we're going to take this, the derivative of the first function, times it by the second function, and then add it to the first function times the derivative of the second function. Okay. So the derivative of that first function, 2t to the power of 5. So 5 times 2 is going to be 10. T, subtract 1 from the exponent, so that's going to be 4. Okay. And then times by h of t plus, so now we leave the first function, so 2t to the power of 5. And then the derivative of h of t, we would just write that h prime of t. Okay. So actually, one thing I'm going to do, I'm just going to color code those g's, just so it's easier to follow. Okay. Normally what we would do next is we would like combine or simplify where possible, but like this is as simple as she gets, okay, for this case. So at this point, we are done with that one. Okay. So the next one here, we've got y is equal to 3x squared times by 2x to the power of 4 minus 4x cubed. Okay, so a little bit more challenging here. Okay, so again, I'm just going to write out my formula here just so that it's easy to follow, and I'm going to color code stuff. Okay, so that 3x squared, that is going to be, I'm going to label that as my first function. Okay, and then this next one here, that's going to be my second function. Okay. All right, so the derivative of the first function, so exponent times coefficient, 3 times 2, that's 6. Subtract 1 from the exponent, it's going to be x to the power of 1. And then I'm going to leave the second function. I'm not doing anything to it. Plus, okay, so now for this next term, I leave the first function, so I don't do anything to it. And then I'm going to derive the second function. Okay, so I'm looking at that 2x to the power of 4, exponent times coefficient, 4 times 2. It's going to be 8x, subtract 1 from the exponent, it's going to be 3. Okay, minus, same process. Okay, so exponent times coefficient, 3 times negative 4 is going to be negative 12. X to the power of, take away 1 from the exponent, so that's going to be 2. Okay, and at this point here, because it's a fairly simple expression here, I'm going to multiply out the monomials. Okay, so I'm just distributing the monomials through here. Okay, so 6x times 2x to the power of 4 is going to be 12x to the power of 5. 6x times negative 4x cubed, that's going to give us negative 24x to the power of 4. Same deal with the next one here. Just distributing that 3x squared through. So we're going to get 24x to the power of 5 minus 36x to the power of 4. And then we just combine where possible. So I'm looking here and I'm going, oh, okay. We can combine 12x to the power of 5 with 24x to the power of 5. So that's going to give us 36x to the power of 5. And then we can combine negative 24 x to the power of 4 with negative 36x to the power of 4, which will give us negative 60x to the power of 4. And there's our final answer for this question here. Alrighty. Next one. So now we got two binomials. Okay. So again, I'm just going to label this just for ease, or just to make this easy to follow there. Okay, so I'm just labeling this f of x, g of x. Okay, just put it in my formula here. Oh, and I should color code that if I'm going to keep consistent. Plus f times g prime. Okie dokie. Okay, so let's derive 2x minus 5. So there's that little exponent 1 on the x. So coefficient times exponent, 2 times 1, that's 2. Okay, subtract 1 from the exponent on the x. Well, that's going to give us 0. So x to the power of 0, or anything for that matter, to the power of 0 is going to be 1. 2 times 1, it's still going to be 2. Okay. And now I write my second function, but I'm not doing anything to it. Plus, and then my first function, I'm not doing anything to that, times by the derivative of the second function, which is going to be very similar to 2x, except for now it's 3x. Okay, so coefficient times the exponent, which is 1, 3 times 1, that's 3. Take away 1 from the exponent, that's going to give us x to the power of 0. Again, x to the power of 0 is going to be 1. 1 times 3 by, like, this 3, okay, that's still going to be 3. And then, even though I didn't say this for the negative 5, I'll say this for the 1. Anytime you take the derivative of a constant, it's going to be 0. So that's why I'm not writing a second term behind either the 2 here or the 3 here. Okay, so how do you know something is a constant? It's because it's just a number. There is no variable attached to that number. Okay, let's distribute this through. So 2 times 3x, that's going to be 6x, plus 2, plus, I'm going to distribute that 3 through, so plus 6x minus 15. Okay, so we're going to get 12x, okay, because I'm just looking at adding these two, and then 2 minus 15, we're going to get minus 13. There we go. Okay, so this next example, it is a little bit lengthier just because we got a trinomial multiplying a binomial here. So I'm not actually going to have space to like write out the formula that f prime g plus fg prime. Okay, but I'll still label my functions just so that it's easy to see where numbers are coming from. Okay, so find the tangent slope to this function, or these two functions multiplied together at x is equal to -1. So step 1, take derivative, and then simplify as much as possible. Step 2, substitute in that x value and get your tangent slope. Okay, again, a reminder that derivatives help you to find slope. Okay, or they give you the equation to find slope at any point at whatever given curve. Okay, so with this, I'm going to go y prime is equal to, so 6 times 2 is going to be 12x. Subtract 1 from the exponent of 6x squared, that's just 1. Okay, and then the derivative of negative 5x. So the exponent is 1 here. 1 times negative 5 is negative 5. The x becomes x to the power of 0, so we just leave it. And then whenever you take the derivative of a constant, that's going to be 0. Okay. And then we're just writing our second one normal. We're not doing anything to it. Plus, so now we don't do anything to our first function. And we derive our second function. So derivative of x cubed is going to be 3x squared. Derivative of 4x squared is going to be 8x, because we're taking 2 times 4. That gives us the 8. Subtract 1 from the exponent. That's why it's x to the power of 1. Okay, now we use foiling or distributive property, whatever you want to call it. All right, so we're going to get 12x to the power of 4 plus 48x to the power of 3 minus 5x cubed minus 20x squared for that first FOIL. Okay, and then for the next one here, I'm just going to go like that and then like so. Okay, so we're going to get 24x to the power of 4, okay, plus, oh, sorry, subtract, come on, there we go, minus 15x cubed minus 12x squared plus 24x cubed minus 40x squared minus 32x. And now we combine terms where possible here. Okay, so we can combine 12x to the power of 4 with 24x to the power of 4. Looks like that's it for x to the power of 4 terms. Okay, so that's going to give us 30x to the power of 4. And then we have our x cubed term, so 48x cubed minus 5x cubed minus 15x cubed plus 24x cubed. All of those put together is going to give us 76x cubed. And then negative 20x squared minus 12x squared minus 40x squared. That's going to give us negative 72x squared. And then subtract 32x, because that's the only term with an x in it. Like an x to the power of 1, I should say. Okay, so now we're at the point where we've combined where possible. Now we need to substitute in this x minus 1 into our derivative. Okay, so sub in x to the, or x is equal to 1, or oh my gosh, x is equal to negative 1. So y prime is equal to 30 times negative 1 to the power of 4 plus 76 negative 1 to the power of 3 minus 72 negative 1 to the power of 2 minus 32 times 1. Okay, so 1 to the power of 4, that's going to be positive 1. Positive 1 times 30 is 30. Okay, negative 1 to the power of 3 is negative 1 times 76 is going to be negative 76. Negative 1 squared is positive 1. Positive 1 times negative 72 is negative 72. Negative 1 times negative 32 is positive 32. Now, putting that all together there, So 30 minus 76 minus 72 plus 32, that's going to give us negative 86. Okay. So what does this number mean here? This value, this negative 86, that is the slope of the tangent line at x is equal to negative 1 on this, this function that we've been given. Okay. So I'm just going to write that as a side note just so you guys can get context for what these numbers mean. This is the slope of the tangent line at x is equal to negative 1. Okay, next example. Okay, this one, we're not told what our f of x and what our g of x are, but we're told what certain things are equal to in value. Okay, so we're told if f of 4 is equal to 2 and f prime of 4 is equal to 3, so the derivative of whatever function f of x is, once you substitute in 4 for the x, it's equal to 3. We're also told g of 4 is equal to negative 2 and g prime of 4 is equal to 7. Then we need to evaluate fg prime of 4. Okay, so I'm gonna go back to writing out the formula here just so it makes sense. Okay, so fg prime of 4, right? So this should be at least a little bit familiar from Math 30-1. This is just meaning that like the function f of 4 is being multiplied by, the derivative of the function of f of 4 is being multiplied by the derivative of g of 4. Okay, so essentially this is product law. Okay, so f prime of g plus fg prime. That's what we're operating with. Okay, so this just means product law is at play. So erase that. Okay, so now we just take our values and substitute in. So I see f prime. Okay, we know that 4 is being substituted into this, so we're told that that is equal to 3. So 3 times, and then g of 4 is negative 2, plus f of 4 is 2, and then g prime of 4 is 7. So that gives us negative 6 plus 14, which is going to give us 8. There we go. I'm just going to move on to the quotient rule notes, and then we can get on to our assigned questions afterwards. Okay. So quotient rule, you have two differentiable functions, f and g, and they are being divided. That's when quotient rule comes into play. For me, these notes 2.5 are on page 53. Okay, so this bit is important. Okay, so f divided by g and taking the derivative of it, so f divided by g prime is equal to f prime g minus fg prime, all divided by g squared, and g of x cannot be 0. So let's take a look at our first example here. Again, I'm going to label these functions so that it's easy to see where everything's coming from. Okay, so the function on the top, that's always your f of x. the function on the bottom, that's always your g of x. Okay. So I'm just going to write out the formula, and I'm going to color code it here so you guys can see where everything's coming from. Okay. So we're taking the derivative of f and multiplying it by g of x, which we're going to leave alone. So the derivative of 2x is just going to be 2 times by x minus 3. We're not doing anything to g of x, or our second function, minus, we leave our first function alone, times by the derivative of the second function, which is in the denominator, that x minus 3, which is just going to give us 1, all divided by x minus 3 squared. So in the denominator, you don't derive g of x again. You just leave it normal and you square it. That's it. Okay. So now what I'm going to do, I'm just going to distribute that 2 through, and I'm going to multiply 2x times 1. So we're going to get 2x minus 6 minus 2x, all divided by x minus 3 squared. So just like FYI, this part here, because our second term in the numerator was so simple, I didn't put an extra set of brackets there. But don't forget to distribute that negative through. By that negative, I mean this one here. Okay, just watch out for that, because that's probably one of the trickier points about this skill. Okay, and now we just simplify. So I'm looking at this and I'm seeing, okay, the 2x minus 2x, that cancels out. Okay, so we have negative 6 divided by x minus 3 squared. And that's that. So in terms of this expression that we got here at the end, because the question said to differentiate, and it didn't mention anything about non-permissible values, I would say do not worry about writing non-permissible values at the end of your question here. Unless the question specifically says write your non-permissible values. All right, so this is the example where I'm going to adjust things, okay, and I will talk about why I'm adjusting this question later, okay, but we're just going to get rid of this and we're going to just say differentiate, okay. So this is my f of x, this is my g of x, okay, so y prime is equal to f prime times g minus fg prime divided by g squared. Y prime is equal to, so the derivative of 4 minus 2x, that's going to be negative 2 times by the normal g of x, so 1 minus x, minus the normal f of x, times by the derivative of g of x, so that's just going to be negative 1, divided by normal g of x squared. Distribute our monomials through, and you know what I'm going to do, just because the second term's a little bit more complicated, I'm going to put the second term in square brackets to remind myself to distribute the negative afterwards, because I'm going to get more than one term for that second part there in the numerator. Okay. So y prime is equal to negative 2 plus 2x minus, in brackets, negative 4 plus 2x divided by 1 minus x squared. y prime is equal to, so I'm just distributing this negative through now. So negative 2 plus 2x plus 4 minus 2x divided by 1 minus x squared. Looks like the 2x minus 2x, those cancel out. So y prime is equal to, so minus 2, or negative 2 plus 4 is going to give us 2 divided by 1 minus x squared. Okay. All right. So the reason why I changed this question here is because if we were looking for the horizontal tangents here, so we're looking where y prime is equal to 0, right, we would have to sub in 0 where y prime is, which would be 0 is equal to 2 divided by 1 minus x and then squared, right, which this would mean we do not have a horizontal tangent, okay? Right? Because if we tried to isolate for x, right, and multiplied, both sides by 1 minus x squared, right, 0 times anything is going to be 0, right? So that's actually going to give us an asymptote there. Okay, so that is why I changed this question, just in case you were wondering. So for quotient rule, typically you're going to leave your denominator like this, just in case there is any canceling out of factors that you can do, and you're expected to just know that you're allowed to leave the denominator just squared. You don't have to expand it unless the question specifically tells you to expand your denominator, which I don't think is going to happen in this book, and it's not going to happen. It's not going to happen on any of your practice examples there. So just a heads up on that there. All right, next example here. Differentiate y is equal to 3x minus 5 divided by 1 minus 2x. Then determine the tangent slope at x is equal to 6. All right, so I'm just labeling these so it's easy to see what I'm doing. Would I expect you to label them on a test? Nope. You can if you want, but I don't expect you to do that. You're not gaining marks for doing what I'm doing right here. Okay. All right. Okay, so again, I'm just writing out the formula just so it's easy to see what I'm doing. You do not have to write the formula every single time on a quiz or an exam. It might be helpful. You can do it if you want, but if you just want to go straight into your derivative, that's fine too. All right, derivative of 3x minus 5, that's just going to be 3. Okay, and then we're going to leave alone our g of x. So 3 times 1 minus 2x minus our normal f of x times by a derivative of g of x. So that's going to be negative 2 divided by normal g of x, but squared. Okay, and then we just distribute through, and I'm gonna put that last part in square brackets to remind myself to distribute that negative, because that negative right here can be super tricky and easy to forget about. Okay, so y prime is equal to 3 minus 6x minus square bracket negative 6x plus 10 divided by 1 minus 2x squared. Y prime is equal to 3 minus 6x, so I'm just distributing this negative through. So plus 6x minus 10 divided by 1 minus 2x squared. Okie dokie. Negative 6x plus 6x, those cancel out. And I'm just going to have to scooch this up a little bit just to finish this off. So y prime, so 3 minus 10, that's negative 7 divided by 1 minus x squared. All right, so that is our derivative. Now, in order to find the tangent slope at x is equal to 6, now we got to substitute in x is equal to 6. That looks like all one word, so I'm going to write it a bit neater. Oh. So y prime is equal to negative 7, 1 minus 6 squared. So 1 minus 6, that's going to give, oh, hang on, did I miss something? Yeah. Thank you very much. I missed that 2x there. Let's fix that. There we go. Okay, life is making more sense now. 2 times 6. There we go. Okay, so 6 times negative 2 is negative 12. 1 minus 12 is going to be negative 11. That's squared. So that's going to give us negative 7. So 11 squared is positive 121. Okay. And that is as simple as she gets. So remember, whenever you have a fraction, always simplify as much as possible.